In-Situ Calibration Validation. Industrial thermal mass flow meters comprise a family of instruments for precision measurement of total mass flow rate of gases in the pipes and ducts. So, when evaluating thermal mass flow meters for in-situ calibration validation capability, be aware that sensor drift will create false positives, reducing the reliability of the validation. When innovators like Dr. John George Olin, founder of Sierra Instruments, saw the rapidly growing need in industry for a truly industrial thermal hot wire anemometer. To make a thermal flow sensor truly industrial strength, Dr. Olin pioneered the innovation of an all-metal clad thermal sensor in the early 1980s. Wet thermal sensor design, because of the organic potting cement used, would shift and crack over time, causing unwanted sensor drift, resulting in a gradual degradation of flow measurement accuracy. Today, wet thermal sensors are used by all industrial thermal sensor manufacturers on the market, with one exception, and that is Sierra. Sierra never stopped improving the technology, knowing that wet sensor drift problems must be solved. After all, by its very principle of operation, a thermal sensor is heated and cooled over time, expanding and contracting the cement inside the sensor, making it crack, settle, and shift from its original state. Dr. Olin believed there had to be a better way. He needed to get rid of all cements to make the most stable thermal sensor in the world. After many years of experiments and testing, the answer finally revealed itself. On March 9, 1999, Dr. Olin patented a breakthrough thermal sensor design. Like other thermal mass flow sensors, it was made of a platinum resistance temperature detector wire wound around a ceramic mandrel. But this is where the similarities ended. Through a proprietary, highly controlled manufacturing process, a metal sheath is tightly formed on the mandrel and wire assembly to be in such intimate contact that no air gaps exist and no organic filler cements are needed. This new sensor was literally all metal. In contrast to wet sensor design, this innovative cement-free sensor is known as a dry sensor. It is patented by Sierra and is brand named DrySense. Because the all-metal DrySense sensor is so rugged, reliable, and stable, Sierra has backed quality claims to be the only company in the industry to offer a lifetime warranty on their thermal sensor. With wet sensor versus dry sensor design in mind, let's briefly discuss in-situ calibration validation. Quality systems, like ISO 9000, may require annual or even semi-annual calibration and validation of all measurement instruments in a facility. One of the nice features of thermal mass flow meters is that the calibration can be easily validated in the field at a very low cost. In-situ or field calibration validation of thermal meters is a highly marketed feature because it saves money on calibration and downtime. Sierra customers have enjoyed this advantage for many years. Sierra's motto has always been, "Don't recalibrate, validate." But be careful, there is a lot more going on behind this statement than you may first think. There is a lot of smoke and mirrors by thermal manufacturers about in-situ calibration. All thermometer manufacturers have generally the same method of in-situ calibration validation to confirm the original factory calibration while checking for drift and assuring accuracy. The basic process makes use of the electrical characteristics of the sensor, either by checking that the electrical resistance of the velocity sensor's platinum resistance temperature detector wire has not changed over time, or by assuring that the power sent to the velocity sensor at zero flow is the same as when it was first calibrated at the factory. The problem with both methods is that they only measure the characteristics of the internal sensor windings and do not address sensor drift. The big question is, how can you validate a sensor that will drift out of spec due to the very nature of its mechanical design? The resistance of the platinum wire shouldn't change, and the current running through the sensor might be the same, both of which would validate OK. This is a false positive, as the drift inherent in a wet sensor design would remain unseen. Sierra's DrySense all-metal no-drift sensor has a big advantage during in-situ calibration validation. With Sierra's all-metal DrySense velocity sensor, You have the mechanical design confidence that there will be no drift and that in-situ calibration validation is indeed actually valid. Sierra offers a free in-situ calibration validation software package we call ValidCal Diagnostics. Unlike some other validation routines, Sierra's ValidCal Diagnostics program provides a complete check of all the meter's components, including the velocity and temperature sensors, sensor drive circuitry, accuracy of the pressure transducer, and all digital and analog outputs and alarm relays. When complete, a detailed calibration certificate and diagnostics report is created. All of this can be accomplished without even removing the meter from the process piping. For accurate and repeatable gas mass flow measurement down to the last molecule, choose thermal mass flow technology. Experience our passion for flow. For more information, go to www.sierrainstruments.com, the global leader in flow instruments.